Here is problem 2, the second inclined plane. So this is the one in the center of the sheet. We have a 20 kilogram object. Again, I told you guys in class to put an angle of 20 degrees there. The sum of the forces in the y direction is going to be 0. So let's go ahead and we know our force diagram looks like this, right? So our mg will be askew. And so we're going to pull that into mg sine theta, or sine 20 degrees. And then my y is going to be mg cosine 20 degrees. All right, so very, very similar to the last one. So you probably, if you had to watch the last one, pause this one first and go ahead and tackle the second one. Make sure that your answers are correct, and then come back and take a look at this one. Okay, fast forward to the end and take a look. All right, so my normal force, sum of my forces in the y direction we know is going to be equal to 0 because it's sliding down the plane. So my normal force minus mg cosine 20 degrees is equal to 0. Therefore, my normal force is equal to mg cosine 20 degrees. So now it's just a matter of 20 times 10 is going to give me 200. So 200 times the cosine of 20 degrees is going to be 187.9 newtons. So 187.9 newtons. And now I have to look at the sum of the forces in the x direction. And that's going to equal mass times acceleration because I only have one force, so it's unbalanced. So sum of my forces in the x direction is equal to mg sine 20 degrees. And so that would be 200 times the sine of 20, which would be equal to 200 sine 20. Gives you 68.4 newtons. So the sum of my forces in the x direction is 68.4 newtons. Then to find my acceleration is the force in that direction divided by the mass. So 68.4 divided by 20 kilograms gives me an acceleration of, divided by 20.0 is 3.42 meters per second squared. Is that what we got in the last one? That is crazy. Okay, probably because of the whole angle. That makes sense. So when you don't change the angle, if you have no friction, then your acceleration of the object is going to be the same. And here's why. This is a little bonus feature. Okay, so if we can say that in the x direction, mg sine 20 degrees is equal to ma, the mass of the object doesn't matter. It's just the angle and gravity. So since we're on Earth, that's a constant. And because we didn't change our angle, then our acceleration is going to be the same value. So that makes total sense that it's that way.